Awesome. So I never know what to call these talks ever. And so I've given it the same name as the same talk that I gave at the Institute of Cognitive Science last year.
Okay.
So there might be some crossover in terms of what I'm presenting. But so my name is James Mitchell. I'm an assistant professor in the Department of Biomedical Informatics on CU Anschutz Campus. And basically I run my lab, which does a lot of things around user-centered design and HCI within healthcare, as well as integration of things like AI, large language models, machine learning methodologies. And I'll go through it all. I thought I'd give you a bit of a tour about me first, so that people can understand where I've come from in terms of the things that I do. I have a very eclectic mix and a very strange background when it comes to working on a medical campus. So I actually started off my academic career at Manchester Metropolitan University in the UK. As you can tell by my accent, I'm not from around here. I actually did an undergraduate degree in photography after going to the Cheshire School of Art and Design in England. And then after doing that degree, I was working for Kerrang and NME magazine for a few years, which is kind of like Rolling Stone. Yeah. Mm-hmm. So I used to have a website that said I shoot rock stars with a Canon. Because that is exactly what I did. And then basically worked at Apple in a variety of different roles. I started in the retail stores, then became a genius, and then a lead genius, leader of the genii.
An official genius.
Yeah, an official genius. And then went into quality assurance and the quality assurance lead. So basically software testing, user acceptance testing, working with software engineers to try and make software better and all those kind of things. In between that, I did about 5 years in the military, in the British Army and Special Forces under the Reconnaissance Regiment. So I have a weird eclectic mix. Yeah, I told you it was eclectic. And then at Apple, my wife when my son was born in 2014, my wife decided to go back to university to do a biochemistry degree. And so basically, Apple were willing to pay some money to pay for some sort of computing. I wanted to kind of solidify the stuff that I'd learned at Apple in terms of software engineering and hardware into something a bit more concrete. And in 2015, I started a computing course at the Open University. I don't know what the equivalent is here. I think there's lots of online courses now, especially since COVID. But basically, I did a computing course. I think I did the first full year of the course without ever reading any of the books or materials and still getting full marks. And that's not testament to me being some sort of weird genius. That's testament to me already having the knowledge and thinking, okay, why am I wasting money and time here? And so I decided to leave Apple and go and do a master's in advanced computer science, which seemed like a very tough decision at the time to leave a very well-paid job to go back to university. But I did a master's in advanced computer science and then managed to secure funding for a PhD, which was in clinical information delivery, so human-computer interaction, very much around mobile application delivery. So taking clinical information, how do you present that on a mobile? And again, I'll talk about this shortly. I did my postdoc at Kiel as well within the same area. And then basically became an assistant professor at CU Anschutz. They were looking for somebody that had done clinical informatics and HCI, which makes me a weird mix because not many people do those things together. And so I'm a bit of a black sheep in the department in terms of what I do. There's not many people that do what I do there. So yeah, I worked at Apple for almost a decade. Just name drop, there's Tim Cook. I've met Steve Wozniak, Steve Jobs, all those kind of people. I did a variety of different things from hardware and software and things like that. So, and like I said, a very eclectic mix and background. So coming from industry, I'm definitely used to the industry pace of things and not the academic. And so I've had to slow down my approach and expectations of other people in terms of their ability to get back to me quickly and turn things around. But basically at Apple, I worked on this application called Planogram. So in their retail stores, they actually built an application that was built an application that maps out every one of their retail stores in the whole world. And each one of them then allows the retail engineering teams to basically place objects, not only on the tables, but the actual layout of these tables, shelves, all those kind of things. Walmart have similar apps so that people can put stock out correctly. But Apple went another level. They've got patents for like 3D modeling these environments and all that kind of stuff. And so we worked on this, including applications within the. So I don't think they still have them anymore. But when you went into retail stores, there'd be an iPad next to other products, and you could kind of get more information about them and other things as well. But the Bluetooth beacons they use in their stores, we worked on test devices called X92. I can't talk much more about that, but basically they were a precursor to the AirTags that they have now. These are much bigger Bluetooth iBeacon devices that would be in the retail stores, hiding under the shelves, and they connect with the Apple Store app. And so as individuals are walking around the store, we were able to use internal APIs that developers weren't allowed access to. And what that allowed us to do was do things like check the serial number for the device to see how long people have owned it, to then offer them an upgrade if that was available to them, or if their contract was coming to an end. Little things like that linking internal systems. Yes, pretty much, but only in the store and only if you have the app and only if you give it permissions, because Apple are very good at stuff like that for the most part. And so as customers would interact around these retail stores, they would have different beacons that would tell them different things about their products. So it would recognize they had an iPhone 6, for example, and it'll tell them that these cases are on offer and just little things like that. But there's lots of little nuances with that. So for example, going from an iPhone 5 to an iPhone 6, the Bluetooth sensitivity was hugely different. And so you had like a welcome beacon that would welcome them to the store and engage them in sort of, this is how to navigate the store and all those kind of things. The iPhone 6 was basically much better at picking up these iBeacons, and so would pick it up down the mall. So people were getting they were in like a completely different store and getting Apple Store like interactions and stuff like that. So we had to like tailor it to different devices, and it became quite complex. So, but yeah, so my whole background predominantly, apart from software engineering, very much focuses on user-centered design. I won't sort of teach people to suck eggs in terms of what user-centered design is. I'm sure everyone understands here what it is. But these are some of the techniques that I employ when I'm doing a lot of these things. As well as building the software, I will then employ these techniques to basically improve the software and so on. And I'll talk about how I've done this in the past. So the first project I'll talk about is the Bedside Clinical Guidelines project. So this is a project in partnership with the NHS in the UK, the university that I did my PhD and postdoc at, which was Keele, and the Bedside Clinical Guidelines Partnership, which is a group of clinicians and hospitals, 56 hospitals in total across the UK, that utilise what are called the Bedside Clinical Guidelines. Now, these, as an example, are medical guidelines that are normally printed in a book or a PDF. And the idea is that they give an aid memoir, especially to junior clinicians, but an aid memoir for them to be able to go to get information, because similar to the US, a lot of hospitals work very differently in the UK, even though it's the same national organisation, and we're very privileged to have national health care and it's free at the point of care. These things tend to change. So, for example, each NHS trust will have their own drug contracts with pharmaceutical companies. And so if you're at one hospital, it'll be a particular type of drug, a particular type of dosage, and maybe a particular type of treatment pathway. That will be very different at a different hospital. Sometimes it'll be exactly the same. Sometimes it's very different. So if you're in a hospital in London, you could get different treatment than what you would in Manchester, even though it's only like 3 hours away. Very strange, but this is how we work in the UK. And so the idea was to take these guidelines, which I'll show you what they look like shortly, and basically try and make a mobile device for them. Now, this has been tried in the past. They received funding from IBM, about £10,000, to basically build an app. And all that happened was they built a really good content management system, and then that linked to a load of PDFs, which, as you're probably aware, don't work very well on mobile devices. And so I looked at the existing research at the time, and there were 2 big pieces of research. This one, which gave short drug information to clinicians, and then a different one, which again linked to PDFs. And as you can see, these things are horrifically complex. So you had like all these calculation tools and treatment pathways, and you're like, okay, this is not good. So what we figured out is people were very good at building clinical guideline management tools or content management tools so that people could find the guideline they wanted very easily. This is a prime example. They had a really good menu that enabled the clinician to find exactly what guideline they needed. but then they would go in and this is what the guideline will look like on the mobile device. And even, as you can see, Ellen's zooming in there to try and actually have a look at it, because it is ridiculous. There's so much, like, it's cognitive overload. It's very, very difficult. And so my whole PhD focused on the user-centered design of these guidelines on mobile devices and the kind of things that we needed to do. So the first thing I did, not being a clinician, having a computer science background, was go in and observe clinicians in their natural environment, like David Attenborough would with animals, and trying to figure out exactly how they behave, how they interact with technology, all of those kind of things. And there was lots of different findings. My favorite one was that junior clinicians and how they access technology was like the polar opposite of how senior clinicians did. So as an example, junior clinicians would use it to establish knowledge. They would be more comfortable using technology within that environment. Senior clinicians, especially the ones that were probably brought up on books and didn't have access to technology when they were learning to engage in clinical environments, tend to use it for affirmation. So as an example, a junior clinician might go in because they know nothing about the later treatments of asthma. They've only ever seen, when somebody comes into the emergency department, they basically say, okay, this is what we do, and I don't know what to do next because I'm in a new hospital. So they will go into the guideline and basically go, oh, look, this is, I need to now engage with the respiratory department. And that's what they would do. A senior clinician might be like, this is, 6 milligrams of digoxin that I need to give them. Or is it? So they'll go into the guideline and be like, okay, was it 6? And they're like, yeah, okay, it's 6 milligrams. And then away they go. One of the other things that we did is a huge survey with I think 160 clinicians across 4 different hospitals to try and figure out what apps they already used. Now this is 2017, so medical apps were fairly rudimentary in terms of what they offered. They're far more powerful now. But what we figured out is actually they used a scary amount of different apps. Most of them weren't even approved for usage, because ultimately the decision rests with the clinician. They don't need, the clinician decides what app they use. But the problem is they had this horrible eclectic mix of apps. So their workflow generally meant going in the guideline, going into an app, going into a different app to calculate a different part of that, and then going back to check with the guideline again before then treating the patient. So this is how the guidelines actually look. You've got a lot of information that is broken up with a very strange hierarchy in terms of, you've got the headings, subheadings, black box clinical warnings, lots of bullet pointed text that are actually diatribes and paragraphs and all those kind of things. You've got these, there's a lot of information. That's just one page. That's just the immediate treatment section of, I think it's, looking at it, it's it might be acute myocardial infarction or something, but the next, on the right-hand side is these decision algorithms. Now this is a simple one, they get very complex. But basically these are decision pathways to help the clinician basically, I don't think I can zoom in, but Ellen may be able to.
Is the graph on the right related to the pros on the left? Because there's a decision tree in the.
Yeah, sometimes it will be. Yeah, so normally it will tell them on the left hand side to maybe so this is for pulmonary embolism, non-active pulmonary embolism, for example. And the guideline might say, use this decision tree, which might be further in the book.
Yeah.
And then they would go to the decision tree, they would make a decision, and then that would lead to further information. And then the other thing that they were doing is it would tell them they had to calculate a drug, and it would give them a formula. And then they have to manually calculate this drug and take the ideal body weight and take all of these different things and so on and so forth.
But it didn't do it before.
And so you can imagine manually, these things are quite complex. You might need to zoom out again. These things are quite complex, but clinicians utilize them on a daily basis to make clinical decisions.
Yeah.
And so trying to put them on a mobile device, there's lots of different facets that we have to take into account. So obviously one of the things that I wanted to do was a agile software methodology, and then this user-centered design approach. Now normally you don't mix these two things together. You would normally agile develop something and then do the user-centered design, and then that would form. But because we're working in a clinical environment, everything has to be very quick, because ultimately you're very privileged to have access to clinicians at any one point, mainly because they're exceptionally busy people. And it's very difficult to get access to these environments. They normally give it to you for a limited amount of time. You get a letter of access, and then you get to go into the environment. And I'll tell you about all of the hard things that I had to deal with that. And so we mixed these two methodologies together. And so we went through like an iterative agile methodology, which took the requirements of the application, made priorities out of those, and then followed a user-centered design approach for those priorities, while in tandem trying to do the same thing and figure out what the next set of requirements are and then do the user-centered design. And so you're almost moving in tandem instead of just this like linear, like one single cyclical approach. And so we did the observations, we did the survey, and then we took sort of current design recommendations and we built a very basic application and didn't change any of the guidelines at all. We looked at how do they look currently in a mobile device and what issues would we have in terms of delivering this information. So for example, you can see on the right-hand side, there's a table with the little scroll thing at the bottom, because how do you visually tell people that it's scrollable? The problem with the mobile device is you can put scroll bars in there, but then that takes up like 10% of the real estate for the table. And so then there's more scrolling to do. There's lots of different things that can affect it. But basically we built this app. It had, I think, half of the medical guidelines in. So there's 156 medical guidelines. And so we built half of them in there so that we could cover all the different facets of each of the guidelines to make sure that we had enough information going forward to test. Then we did focus groups, we did system usability scales, and then we made adaptations based on the things that we found. One thing that we did do, so the focus groups were very difficult. Focus groups are difficult anyway, you know, trying to organize them, get people in the room, get the conversation going, trying to facilitate differences of opinions, individuals that tend to be dominant. I can tell you clinicians are very dominant individuals, especially in focus groups. And what you also find with clinical focus groups is that you'll have a senior clinician that is really championing this approach of whatever it is you're trying to do. And so they'll bring all their junior staff with them. So you can imagine then the pressure to contribute, the not wanting to say controversial things becomes very like nuanced in terms of all these things that you have in these focus groups. So we adapted the focus groups and used something called idea writing. So idea writing or brain writing is basically an old concept from like the 80s where you would have an idea at the top of a page and then people would write their opinions underneath, kind of like a forum or whatever you might have. And so the way that we did it with this, and I think I've got some examples later on, but the way that we did it with this was we had parts of the application that we wanted feedback about. So it might be the content page, it might be a clinical warning, it might be how the information is presented, it might be how the decision algorithms work. And we had a page for each of these with some instructions on, and then we did a silent focus group where we passed these pages around and everybody's giving feedback all at the same time, and then you swap the pages and then hopefully people start agreeing and have a conversation and so on and so forth. And that way then you can actually gather more relevant and trying to think of the word now, it's lost on me. But you can get more richer feedback from people in a smaller amount of time. And the reason that we did this is because in the first focus group, trying to organize to get 5, 10, 15 clinicians in the room at the same time was very difficult. And the only way we could do it is Pfizer were coming in to give a presentation and paying for lunch. Well, clinicians get continuous educational credits if they go to these things. And so there was 20 clinicians in the room. Pfizer needed 20 minutes and they blocked out an hour. So we got 40 minutes at the end of this presentation. Well, actually about 35 minutes in the end by the time everything had wrapped up and people had, you know, got lunch on plates and all those kind of things. And so then you add dominant individuals into that who want to talk about ethics, and you're like, we're not here to talk about ethics, we need feedback on the app. We'll worry about ethics later on when it's getting implemented. You know, we've gone through ethical approval to be there and build this thing in the first place, but yeah, so you can imagine trying to ease that dominant approach. And so that's what we did. We adapted the focus groups, which led to more usable feedback in terms of trying to iterate through the app design. And so we did, one of the things that we did with the decision algorithms is obviously they don't really work on mobile devices very well. So I built this really basic, what if we did it in this way, like answering questions without having this flow chart in front of them, and then give them the stuff so that they could do it with one finger and in hand and stuff. And then we iterated through this in different ways. So you can see the second iteration was it had the original decision algorithm. and when they tapped on it, it would activate the programmatic version. But then we realized that actually it needs to be redesigned slightly, so we did a slightly different design. And then eventually the design that we ended up with was, through speaking with clinicians, was actually having the programmatic version available. But then the original, because everyone was like, oh, hey, we like to see the original version, we need a Gestalt view to make a decision. And so we had the programmatic version available so they could quickly go through and get the decision. But then if they wanted to go further in, they could see the original flow charts. And so that's how we presented that. And you can see it made things like, for example, the guidance on prescribing here. They could see what questions they've answered, the flow that they've gone through, and then the clinical recommendation from there. And so it's easier for them to go through. We put, Ellen, if you're wondering about where the restart button is, we put it on that side on purpose, because then they have to make an actual physical decision to go and push the restart button to reset everything. One of the other things that we did with the clinical guidelines was look at these black box warnings. So there were 352 of these things in 156 guidelines, and there was no hierarchy, no structure. You can see how much text is in some of them. Now, these were supposed to be like, you know, there was a big difference between them. So one of them was like, make sure you wash your hands before treating a patient. The other one was, if you don't give this patient this drug within 1 hour of like diagnosing this, they'll die. And so there's a big gulf of difference between those two things. And so we tried very desperately to add some hierarchy to some of these things, because it's very difficult to do. And so as an example, this is the BNF, which is the British National Formula, where you go for drug information, things like interactions, cautions, all those kind of things within drugs. They have a similar approach to it. And you'll see these things in lots of other things as well. So this is the BNF Act. They've done the same thing in the app. They've kind of highlighted it in a certain way, but there's no hierarchy to it. And you'll see these things all day, right? You get modal approaches, you get different warnings, you get things in emails that pop up at the top. So how in a clinical environment you do it in a way that isn't contributing to alert fatigue, isn't just going to be something that clinicians dismiss, because believe it or not, when you have modal approaches to warnings in clinical environments, they just close them. It could say, this patient is going to die. That's in the way. I'm trying to get, because the problem is, like, these systems do things in the background. And so they might be opening the note, just like they're aware that the patient is dying. They're trying to open the note to get information that they need access to.
Right.
And so going in there and then this thing popping up saying, this patient's going to die. And I'm like, yeah, okay, that's fine. I understand. And they're like, do you agree? And, you know, have you confirmed that this patient is going to die? And you're like, yes, I've done that. And then eventually 2 minutes later, they get to the information that they wanted in the first place. And so we basically got clinicians in rooms. One of the things that I think was beneficial from this project was actually forming relationships and working with single experts, because having issues trying to get access to an environment where there's multiple people, having access to single experts and working with single experts, doing single expert studies, meant you could get to the root cause faster in terms of things that you were trying to find out. And so that was one of the outcomes of this. But we did card sorting, semi-structured, structured card sorting, trying to figure out how they would basically structure some of these warnings. So for example, here is high risk and low risk. And basically we figured out, after looking at a scary amount of different warnings, the 350, we reduced the amount of warnings that were in there, and some of it was amalgamated into the text. But basically we figured out that it's very difficult to try and sort all these warnings, because you have to take into account loads of different things to do as well. It could be clinically relevant, or it could be like administratively relevant. And then how do you put those both in a red box? And so there was loads of different sort of issues that we had in terms of the nuances with these things. So we just decided for a traffic light system. It made the most sense. We had what was a red and then an amber warning, and then what would be a blue, what we called a blue hand warning, which was like a stop sign, a hand in a blue warning that basically just said, like, are you in the right guideline? Or this guideline is for this type of patient. If you're looking for this treatment, it's in this guideline. Whereas if it was like, if you don't do this, they're going to die, then it was in a big red box and they could see it. Now, one thing that we did realize doing some of the things was we needed to change the layout, but I'll talk about that shortly. But basically, after doing the focus groups and iterations and warnings and card sorts and all that kind of stuff. We came up with like these 13 recommendations for delivering clinical guidelines on mobile devices, and it was obvious things like, for example, having a way to filter the information out, having it cross-platform, although I think around 75% of clinicians have an iPhone. Minimize manual tasks, so if it's a manual calculation, try and have it so that they can just put the information in and it calculates automatically. Minimize the requirements for other systems was a big one. You wouldn't believe how many times they have to go through 3 different apps to make one decision. And so having everything in the one app, structured in a way that is in line, so they're not going to a separate page. It isn't a calculation tool in a modal. They can actually get the results of the calculation tool and then see where that fits within the guideline itself. And so they're able to access information and so on and so forth and read things related to the calculation that they've just done. And then we did all of the Think Aloud sessions. It was very difficult for us to access clinicians at this time. It was 2020 when we did this. I was predominantly working with a respiratory department.
Oh, wow.
So as you can imagine,
They were busy.
kind of, yeah, they were the first ones hit. They were getting hit in February before we even, they were like, we just don't have. And so we realized medical students, 4th and 5th year in the UK, basically do ward rounds. They're using these guidelines on a daily basis, more so than probably the clinicians in the hospital. And so given that these were one of the user groups, we did one-on-one 15-minute sessions where we basically asked them to do very basic clinical scenarios. So if you have this patient with this illness, here is a load of clinical information that's relevant to the calculation. Go and find the clinical guideline that you need and, figure out the treatment effectively. And we found a load of things from these. So for example, the clinicians pushed back about the original version and the programmatic version. Only one of them used the original version, and then they were like, oh, I didn't need that, and went to the programmatic version anyway, so technically it's 38. But we wanted to see how people filtered things out. Did they use filters in the main menu? Did they use filters in the guideline menu? If so, how did they use them? And so we just looked at whether they utilized that tool or not. We looked at things like sentiment analysis, positive and negative sentiment towards various parts of the application. So whether they're talking about clinical warnings, whether they're talking about layout, whether they're talking about the structure of the guideline, if they were talking about the context of the actual guideline itself, then that goes in the other category. And so we basically did all of this positive and negative approach to, so you can see that the middle one was about warnings. And that basically was that when they were going in to actually find the information they needed, so some of the tasks that they had was, go and find out where you have to refer a particular type of patient with this illness. Well, the actual information was in a warning box, completely missed it. They were looking in the information. And so one of the findings from that was actually to repeat the information that's in the warning in the main context of the guideline itself. And so that way then the warning is more prominent, but then if they're reading the guideline, the information is still there. We did SUS across the baseline first time and then the second time after we made iterations, just to make sure we hadn't messed up any of the usability. And as you can see, it improved in the scoring. Although in hindsight, like with everyone that's done a PhD and ever reads their thesis again, which I have not done in a hole, I would rather print it and burn it. I would have done this as a full positive correlation instead of positive negative, just things like that. But we looked at whether we actually induced any errors. So like if there were any errors, was it to do with information retrieval? Was it usability? Was it bugs or app issues? Was it just related to how the information semantically was presented? And we looked through and things like that. And basically, we built an app that now clinicians use in, I think, 56 different hospitals. When we've just finished the neonatal guidelines, they're getting implemented. And then there's, I think, another 6 sets of guidelines, surgical, nursing, emergency department guidelines that are all going to get implemented. And so clinicians will eventually have access to about 1,000 different guidelines, around about 600 decision algorithms and something like 60 different calculation tools, all within the same application that is available to them on their mobile devices at the bedside, so that they don't need to disappear off to a nurse's station to get the computer to, I think it was 11 steps to get from the login to the clinical guidelines themselves. So this is why they all had them as PDFs on their mobile devices, and they were walking around with potentially old information. And so what we do with this now? Well, basically, clinicians have to access a stupid amount of information. In fact, how clinicians are taught now. If you go back sort of 30, 40 years, they were taught how to treat patients. Now they're predominantly taught how to access information to treat patients. They're still taught how to treat patients, obviously, but a predominant amount of their time is now spent figuring out how the information is utilized and how to then utilize it in the hospital environment. And so one thing we're doing is looking at the structure of the guidelines and how we can make it easier for different people accessing them, and doing a UMAP approach. So user modeling, adaptation, and personalization. So we're taking use data, the structure analysis of each guideline, and then user data. So basically what type of clinician they are, what department they're in, how long they've been doing what they're doing, all of those kind of nuances about the actual individual, taking how they use the guidelines on a longitudinal basis, and then the structure analysis of the guidelines, then putting that into an algorithm AI decision system that then gives them a personalized view of the guidelines. And that could be very simple, like these are the guidelines you must access. It's a recommender system. Or it could be something more complex. And as an example, I'm sure everyone's accessed Netflix at some point. Netflix doesn't have one poster for an individual show. It probably has about 40. And they change based on your behavior. And so if you're watching a load of Uma Thurman films, then the Pulp Fiction poster will have Uma Thurman on. Whereas if you're watching John Travolta films, then it will show you John Travolta. And this is even down to, for example, if you tend to click on things to get more information when the title is large and there are no people on there, then all of a sudden your Netflix will be full of text and not pictures. Whereas if it's lots of pictures, or like you like those proper posters that are like from the 80s with all the individuals, like the Drew Stersman kind of poster, then that's how it will present the posters in Netflix. And we're looking at doing this with clinical guidelines. So you'll have like the normal view, section A, B, C, D. Well, the junior clinician might like to look at the more introductory information first, and then go to like treatment pathways before they go to drug information. Whereas a senior clinician might go straight to the drug information. And so having it structured so that there's ways for them to actually, and you'll see news apps are doing this now. So I know Sky News do it, but I mean, I think CBS do it as well, where they'll have a summary of the story at the top and then links to the different parts of the news story, because these things like tend to spiral out of control during the day. And so they click on that bit and it just shows them that section of the news story that they're interested in. And so we're looking at doing that with clinical guidelines to make them more relevant to the individual that they're looking at. And, you know, like just as an example, that on the left is a clinical guideline from the UK. That is on the right is a clinical guideline from Children's Hospital in Colorado. They are very similar across the board. And they're normally made by individual parts. So like their Children's Hospital Colorado pathway, that's only used in Children's Hospital. Those guidelines are basically disseminated versions of about 4 or 5 different guidelines with a load of information from like academic articles to, maybe that clinician is like a world-leading expert in a particular type of illness. And so they will put that in there and have their own guideline that is used in a local basis. So on that, one of the things that we're trying to do now is build a feedback tool that enables you to access basically those hard to access environments, remove that barrier in terms of, so this is a different research project now, but it's very related to the horrendous nightmare that we had at trying to do focus groups in clinical environments. But we're basically building a feedback tool now. As I said, it's born out of the clinical environment, but you have lots of different areas of feedback that you would gather. So as an example, you might have a remote clinic that you need to access. You need to basically build an app for. Well, good luck trying to get into the, sub-Saharan Africa in the middle of summer with and get focus groups sorted or whatever, or forward operating points for military, or it could be scientists in the Arctic or whatever it might be. They still need these things building. And so having a way to gather information from them in the same way that you would in a rich focus group. And even on Zoom, these things can become a nightmare because everyone has to be in the same place at the same time and have a conversation within only that hour. And then that's it. That's the end of it. Thank you very much for your participation. I've got my transcripts that needs to be done. And then 3 weeks later, you get your transcripts and you're like, why didn't I ask about this? Or, how am I going to clarify this? And I don't even know who said this and all those kind of things. And so this is idea writing that I mentioned earlier that we utilize. So this is about like a care for a housebound plant in a plant library idea, and then people gave feedback about it in terms of, and you can have a conversation on the page. And like I said, we did this with these sections of guidelines. So we took all of these ideas, you know, the main menu, the guideline layout, the filter function, table designs, and we basically asked clinicians to feedback during focus groups. So they wrote on the pages what they thought. People would agree and tick it and stuff like that if they agreed with the comment. And so it just enabled us to get richer feedback quickly. And then during COVID, we actually did this on Zoom on Google Sheets. So we just got a Google Sheet, we had them fill in the same information, and then the next column we had whether they agreed or not, and then maybe a reply. And so instead of it becoming like a focus group conversation, it became more like a Reddit forum. And so at the moment, we're building a feedback tool that enables us to do it either live or asynchronously. You can add time limits to it. It's simpler for data extraction because it's already transcribed. But what it enables is more time for clarification. So as an example, you're a clinician working in an emergency department, one of 5 that are participating in a feedback for an application that's getting implemented. You might not be available at 2 p.m. like what other clinicians are. And so you can access this on your lunch, you can give feedback, and there's lots of nuances to it that I'll talk about. But the idea is that as a facilitator, you will have different projects that you can have. And then basically you'll go in there and you'll have feedback about different areas. You can have a look whether there is feedback in there. You can also have a look if there's conversation in there as well. And then as a facilitator, you will be able to do different things. We're still mapping this out. This was something that my PhD student and I basically drew a couple of weeks ago in terms of we're getting the software engineering team in the Department of Biomedical Informatics to build this basic system now. Now my PhD student over the last 3 months has built a very basic prototype that we're utilizing in a study at the end of this month. And basically the idea is that it does a lot of different things. But if the only way I can describe it is like Reddit. So you will have instructions at the top, and then before you get to see the conversation, because it has I don't know whether I put it in there. Before you engage in the conversation, it asks for your feedback, and that might be in a single stage. It might be, go to this web page, do this specific thing, and then ask 3 questions. That forms a paragraph of feedback. Now, one of the things that we've got at the moment is a method so that the facilitator can go in and ask for clarification. And so like on Reddit, when somebody says like, what do you mean by that? And the problem is that you have let's say we're getting, we're asking specific feedback about the design of clinical warnings. Somebody might put the design is good. Well, what does good mean, right? It's completely different for every individual. And so being able to clarify that is something that we're doing at the moment. This is the initial parts of this. But the later parts will actually do ACV laddering automatically. So we're going to have a large language model that will go in, and basically if somebody says the design is good, the language model will recognize that it's an obtuse comment. It's not very precise in terms of what it is. It will then kick in and have a conversation with the individual to build a better content of feedback, so to speak. And so this system will do a couple of different things. It will have the idea writing system and the large language model chatbot. It will then have that progressive reveal, so it won't reveal the comments of other individuals until you've given your feedback. And then one of the things that it will also do is engage people in conversation. So it will recognize comments that are a dichotomy, for example. Somebody says the design is good and somebody says it's bad. It ladders down to the reasons why, it extracts them, and then gets them to engage in the conversation. One of the other things is that it does is this large language model system is actually based on an ensemble, which basically is multiple language models that basically vote as to whether it's vague or ambiguous. And then if, let's say, 2 out of 3 vote, then the laddering system kicks in, and then it will ladder down until eventually it goes through this ACV process that then says, oh, look, this is now a far richer comment that people can understand. It has a reason behind it, so it has an attribute, it has a consequence, there's values in there, great. Now other people will be able to read that and go forth. But then also with that system, it's automatically transcribed. which means then we can do lots of things like automatic sentiment analysis, for categorization and tagging. We can do theme analysis, thematic analysis, and then provide a visualization system on the back end for the facilitators. And as an example of using large language models, on the right-hand side, this was an idea that myself and two other colleagues have been looking at. We tried to get funding from Meta. The university halted it because the agreement with Meta was that if they didn't like the outcomes, then they didn't have to pay the money. And so the university were like, whoa, it's like $100,000. We're not applying for this.
Incentive to disagree.
Yeah. So, but as an example, this diagram on the right-hand side is an example of using an ensemble method. So what happens is this is a way of reducing hallucinations in large language models when they're providing citations for information. And so you've probably all tried it. You've gone in there and said, you know, what's this, blah, 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 and give me a citation, and it makes this paper, it completely makes something up. And you're like, I've never heard of this paper at all, nor have I heard of this individual. Like, what do you mean there's 50,000 citations, really, in HTML? and so what it does is it takes the content, the citation itself, it then tries to find the paper. And if it can't find the paper, then it's like, no. If it does find the paper, it takes the abstract of that paper, and then it compares it to the context it's written in. And then the large language model system, an ensemble of them, so let's say here is 3, so A, B, and C, will then vote on whether it's related to, not related to, or it can't figure out whether it's related to or not. And then you'll end up with basically a scoring system where an individual human can then, a human in the loop can then get involved to train it further, to fine tune it. And then basically you get an F score. It's 98% certain that this is related to the content. And so not only will you get a citation, but you'll also get then an F score to the relation of the citation that it has. And hopefully that will remove some hallucinations from it and make it a little more usable in terms of helping people, prepare information for whatever reason that they're utilizing it for. But we're doing that with a feedback system as well. So, and as an example, you will get access to something like a dashboard, like so. And it just means you've kind of removing some of the barriers that facilitators have in these kind of environments where they can't access it, then 2, they only get 40 minutes, and then 3, when they get the transcription back, they're like, oh my God, what is all this? I should have asked all these questions. I can't now clarify. I can't go back. The other benefit to this system is that when people log in, it's anonymous. And so you don't have to worry about pressure to contribute or worrying about, towing the sort of leadership line. You can actually give honest feedback that enables. And one of the other things that we were just discussing yesterday about implementing was, let's say as a facilitator, you ask for clarification from an individual that then puts that individual in an uncomfortable position of having to explain something that they might not want wholly public. They can then respond confidentially. And so in that, if you imagine like a Reddit forum where people have been replying to each other, it just have this box saying the respondent has replied, but in a confidential way. And that way then it doesn't look like they just haven't replied, but there's a visual way to see that they have and so on. One of the other projects that I'm doing is looking at consumer wearables. I've actually stopped where at one point I had 3 things. I had an Oura Ring, a Whoop, and then my Apple Watch. But we've decided to go with Apple Watch because it's far more accurate in terms of Whoop was doubling steps, for example, and Oura pretty much said I never slept. And although it feels like that, I'm pretty sure I did sleep at some point. And so these things collect a huge amount of information, right? Heart rate variability, energy, how much energy you're using, how much walking you're doing, how much time you're spending sitting. These are all the things that they track in terms of different aspects of your life. And so because it's tracking all this information, a lot of studies haven't really utilized these things for anxiety. And so one thing that we're looking at doing is taking a variety of this information that might contribute. So for example, heart rate variability, sleep tracking, noise level monitoring, SpO2 tracking, all these kind of things are things that are related to in some way to anxiety within individuals. At one point, we were experimenting using other wearables as well. So we were going to take, so these are basically sweat monitors that you attach to your skin when you're cycling or running or whatever it might be. The top left one is one from Gatorade, so I imagine that one just tells you to drink more Gatorade at any point during whatever exercise you're doing. The one on the right is probably the best one, and basically that monitors your sweat throughout exercise. It's very good at telling you what electrolytes you have lost, and what is the best sort of way to replenish those electrolytes as a database of like 1,000 electrolyte drinks. Some of them, with way more salt in than others, and so on. And so, whatever electrolyte balance you've lost, it recommends a drink to replace the electrolytes that you've lost. We figured out that actually using those things won't work because although the technology is great, most likely most individuals won't sweat enough to pick up the data that you need to then do it. But the idea is what we're doing is taking the Apple Watch data and diary studies to try and basically triangulate how individuals become anxious. And some of them might be obvious, like in the diary study, they'll put, well, I have to give a presentation tomorrow at work. And so I'm a little more anxious, although but one of the reasons I'm probably doing this study is much to my detriment, I never get anxious at all. In fact, I'm far too chill for my own good in some cases. And so I'm trying to understand why individuals get anxious. But yeah, so taking all of this data and basically triangulating in ways that to help individuals on an individual basis figure out what might trigger their anxiety when they're not aware of it. So for example, there are studies that gait balance and mobility and muscle strength are different in healthy individuals compared to people that suffer from anxiety. There are stuff regarding noisy environments that basically lead to anxiety episodes the day after. And so my theory at this stage, and it's still very much a very, very theoretical theory, is that basically you have like a coping battery, so to speak, that individuals will have at coping with these things. And if you've been dealing with a noisy environment the day before, and that's something that makes you anxious, you're less likely to be able to deal with smaller things that would probably not really trigger your anxiety very much the day after. And so that's what some of the things that these studies have found. But the idea is to provide, look at my awful AI generated picture there. My idea is to management. Yeah, there we go. My idea is to basically have individual anxiety tracking to allow individuals to then say, well, if you drink more alcohol the night before, you're more likely to be anxious the day after. Whereas some other individual might be poor sleep, noisy environments, working too much exercise. There's lots of different factors that could trigger these things. And this is not clinically relevant anxiety because that's easy to track with diary studies or heart rate, but actually less clinically relevant. People that haven't been diagnosed with, sort of clinical anxiety, but more people that suffer from the kind of anxiety where they're like, I can't cope with this anymore. I just want to go and lie in my bed and not do anything. That kind of anxiety. And there's different approaches to this that we can do as well. This was actually born out of an idea with the Marcus Institute of Brain Health. Now, being a foreigner and still working on my green card process, although it's very close now, I'm very, very close to getting a green card. I can't apply for DoD grants as a PI. And so that's on hold at the moment. And so we're getting preliminary data with individuals that aren't related to veteran studies. And then the idea is to actually bring that information to a veteran study. And the Marcus Institute of Brain Health have basically a program where individuals, veterans with traumatic brain injury that suffer from anxiety and go to this 3-week program to basically learn coping mechanisms, do art therapy, normal, sort of psychiatric therapy, a lot of discussion around different areas of their anxiety, and they learn coping mechanisms. And the idea was to track data before they come on this program, to track during, and then to track after, and see how individuals improve from a physiological point of view and from a diary perspective, so that we can then look at interventions where, like for example, they might not be aware that being in a noisy environment the day before triggers their anxiety the day after. They might just think, well, that was yesterday. I don't know what's wrong with me today. And so having these pattern recognition things means that they can have an individual sort of program that they can then follow. And it might be something with that where it's like, okay, you need to contact your provider because, the symptoms that you have and the triggering mechanisms from previous days suggest that you're going to. it's very difficult to have an intervention that's in the moment because, as you can imagine, like somebody telling you to calm down when you're very emotional, having something pop up saying you're suffering from anxiety right now is probably not the best approach. Trying to have it so that it teaches the individual instead of having it as an intervention in the moment is probably a better approach. And there's other things that we can do with it as well.
What you're describing sounds a little bit like the experience of people with autism also.
Yeah, well, so it's born, and my oldest son, who's 21 now, is autistic. And so like that's another approach in terms of definitely, because a lot of autistic people aren't aware of what triggers them. They just know something has triggered them. And some of them might not be, like for him, it's the R line isn't, the E line isn't working from the Denver campus. That's normally his trigger, but I already know that without having an Apple Watch or a diary to do that. So, but yeah, there's lots of other things. And so having something that's measuring you from a physiological perspective, as well as other things like, for example, sleep, and other aspects like, being outside, noisy environments, all those kind of things that the Apple Watch collects. And it's not to say they're the most accurate things in the world, although there is a weird tacit assumption that FDA approved devices are better, and they're really not. Not even close. It's just they're FDA approved, so everybody uses them, but actually the accuracy is in the consumer ones because they have far more money to spend on improving these things. So, and they're not wholly accurate, but having it from an individual perspective, the consistency is there. So heart rate is good for an individual from day 1 to day 2. It might differ from 2 individuals that are fairly similar on a physiological perspective, but yeah, they're fully accurate enough. And then the other thing that I do in my lab, and I'm going over lots of things now just to give you an idea. I like to make things beautiful. I always think beauty first, because especially when you're building applications that are going to use an environment, if you show them something that looks nice from day 1, then at least then they're advocates of it instead of getting it and going, what the hell is that? And thinking, I don't ever want to use this thing. And so as an example, I'm doing a study with Utah and Vanderbilt at the moment called DD Interact, which is a gastrointestinal bleed system that enables them to predict the likelihood of a gastrointestinal bleed. So I'll have a look at that in a second because that's a very long comment. But basically, okay. I've probably put my foot in it now. But basically, redesigning this system to be more usable and having pathways for them to go through. So, like for example, we've gone from this system to this system here, just with interviewing clinicians and patients that we use it. Another one is having a look at these clinical information alerts. So this was a 3-level alert with a load of questions, and basically we reorganized it in a more usable format, and then we reduced the amount of questions that it asked. So you can see between these 2 here, we basically had it to reduce the amount of times that people had to interact with this alert that came up in Epic. We've got a heart failure project. So this was the initial layout. We interviewed clinicians to basically look at different ways of laying it out. And as you can see, the different improvements that we've done in terms of layout and making things a bit more salient. We even looked at different, because they said they didn't like the red in the left-hand side. The red was too harsh. And I was like, well, it's the most salient one that we could use. But so we even looked at utilizing different colors and different ways of doing it, which we've not looked at actually utilizing. And then one of the other things, which is probably why you're here, and I'm covering this very briefly as well.
Thank you.
So one of the other things that we did, this is completely different from all of my other research, but I work as part of the virtual cuneiform project across, there's about 6 different universities that work on this now. And we basically have the privilege of going into museums and 3D scanning artifacts to basically put them in augmented reality. So a virtual museum, because let's face it, two of the issues with museums is either these things are stuffed behind glass and you never get to see them, or they're stuffed in a drawer somewhere and you never ever get to see them. And so this example was a shaft he brought back by Florence Nightingale from Egypt that she gifted to her sister, bemoaning the fact that she wasn't allowed to bring back actual artifacts anymore. This is not real, it's a replica artifact that she bought in an Egyptian street market. And so we built apps to educate on how 3D models are built, but then allow people in different environments to basically present, to have their own museum. It worked very well during COVID, as you can imagine, because a lot of museums weren't open. And so we could have different things like a shabti or a cuneiform where people could go in there and basically turn these models around, view them as this big on a table or, you know, a couple of inches, and actually, and so schools were taking these apps back and basically interacting with these objects as a classroom with iPads and things. And the one thing that we're looking at doing at the moment in my lab is using it for patient education. I've got a Vision Pro in my office at the moment that I've been playing with. I'm basically using it for patient information. One thing that you have with patients is drug adherence. And so there's quite a lot of patients that don't take the drugs that they need. And I think it's an association with actually understanding the illness they have in comparison to actually what impact the drugs might have. And so having them see visual representations of here's your heart without the drug and here's your heart with the drug, and seeing how it beats differently and things like that might mean that they can visually, it's a visual education for them to utilize. But the other aspect of it as well is because it's novel, if it's in an application, they would tend to go home and show other people, and then it helps them in that adherence to that sort of thing as well. But that's me in a nutshell. I've given a very broad overview of all the little things that I do. This is my son Edison, who is
Nice.
so he goes in all my presentations because I'm not there. But yeah, so yeah, that's me in a nutshell anyway. If anyone has any questions, I know some people have put some things in the comments which I'll have a look at now.
Remain on that.
Oh yeah.
Yeah, let's move on.
So, Aubrey asked in the comments, great overview, thank you. As initial presenting clinical workflow application considered clinical decision support software. Yes, although the NHS in the UK is different to the FDA, although the government do have a process. Basically, we had to declare it as a clinical device, although weirdly, it's only a class 1 clinical device because it's not in vitro. And so basically, it allowed us to perform our own box ticking exercise of saying, yes, it adheres to all these things, and then you sign it and send it back, and they consider it a class 1 medical device. I believe the laws are changing very quickly as well. So, yeah, so hopefully that answers Aubrey's question in terms of that. I'm just looking now, the ordering information. Yeah, we've not even looked at how laying out the guideline changes the approach in terms of whether it meets policy or not. Although I would say the speed so we've actually got mechanisms in the app to monitor how they scroll and what is in the viewport. And the speed that they scroll, it wouldn't make a difference if the clinical information was reordered in any way. I think more than likely just making it salient to say this section is actually at the bottom of this guideline, and to make sure that you're reading the relevant information around it before you access it. But here's the information that you tend to access more often. And it might just be a link so that it takes them down to that part of the guideline that might be.
I mean, can you hear me?
Yes.
Yeah, I mean, if it would be helpful, I can talk through any of it. And sorry, I'm a little bit under the weather today. Great presentation. Love all the stuff you're doing. I just there were a whole bunch of things, and just, you know, the full disclosure here is that I clearly have a policy background in this device software and clinical decision support software, but I also, you know, for anybody who knows me, I have a really deep user experience background as well, and that's really probably the core of who I am, and I bring that to my policy work. I'm not sure if I feel like I might have heard somebody mention in the room that I'm at the FDA.
Yes,
but
it is.
yeah, but if you've, you know, been following the news, I'm not really expecting that to go a lot longer. So in any event, you know, I love of what's going on there, from the consumer wearables to the just like clinical workflow stuff. And as you mentioned, there are certainly differences from the point of view of regulatory harmonization across like MHRA or Health Canada. And I actually also worked on some of the international harmonization activities, specifically around AI-enabled device software functions, which I would say this probably falls in. I was wondering, are you Well, at a high level, I think something that's interesting for folks in this room doing UX work, I just wanted to flag that the specific colors used in user interfaces actually trigger policy differently. And I don't know that you were familiar with that or not, but I've found, with my own work and where I might be wearing my user experience hat and say, well, this user interface presentation is more effective and easier to understand. It actually raises policy concerns outside of whether it's easier to use or not, which is just a really interesting thing to be aware of.
So I remember finding an article about color theory in terms of that particular, like whether it improves or has issues with adherence in terms of one of the reasons we went with the main blue layout is because that's what the NHS has as a whole across the UK. But you're right with the warning colors, for example, with the colors within the actual calculation tools and things like that as well. Because this stuff has only been implemented since post-COVID, I don't think we have enough information in terms of them accessing it. But the idea is to look at lots of different things like that. So I think, Aubrey, if it's okay, I'd love to give you an email at some point to continue our discussion.
Yes, I can connect you to. All right.